Okay, so we're going to deal with 8.6 today, exponential and log functions and how they look. So, as you can see in the book on page 262, the very first one is if it's greater, so let's say we've got y of 2 to the power of x, that's going to constantly exponentially increase. Exponential. So when we talk about exponential growth, for example, they're talking about the R rate, yeah, so the R rate of the coronavirus, the reproductive rate, if that's 2, then we're going 2x, yeah. If it's 3, then it goes up steeper, obviously, like that, and it goes out of control. But when they talk about getting the R rate below to half, what actually happens is that it goes down like this. Okay, and as this is discrete data, you can't have half a person or a quarter of a person, so it disappears in time if that's what the R rate is going to be. Obviously, it's a little bit more complicated than that, but that's when this is, it goes down like this. When this is less than 1, it goes up like this when this is 1. If this was just 1 to the power of x, what would happen? It'd be the value of 1 here, and that's y equals 1. 1 to the power of anything is 1. Okay. If they give you something as follows, I'm going to try to make this as simplistic for you, and your calculator can do this as well. If they give us x is -3, -2, -1, 0, 1, 2. Okay, and they say y equals to, I'll put it here on the side, y equals to 2x. You got two ways in which to do this. Your calculator can do it for you, or you can just put into your calculator 2 to the power of -3, and you'll get minus that, and then 0.25, and then it's going to be 0.5, and then 1, 2, 4, so on. Everybody here is capable of drawing a graph here for that. Remembering, this is our y value, this is our x values. Yeah, so just be our -3 here, and our y value be here. Yeah, and starts to go up like that. Okay, everybody, that's the easy stuff there. Now, if I said to you, just one or two little terms you're going to come across, or if I say x is an element of R, everybody goes, oh, that's the real numbers. X is an element of R plus, that's the positive real numbers. So don't forget that. What's E? Y equals e to the power of x. What's E stand for? E is like pi. It's a number. I think it's like 2.17. I could be wrong. I don't really particularly care about being correct or incorrect on that either. It's just, that's in your calculator, so you don't have to memorize it. Next one. So that's exponential. What if we got a log? So the logarithmic functions would be as follows. So if I tell you y equals log x. Well, first of all, if it's log x, what's that to the base of? 10. If I tell you y equals ln x, that is log base e. Okay? Now, your calculator will have this in it as well. So they will base, or they'll take it as, well, if you go ln, it's got the base e. Log is base 10. You can change the log if that's base 20. You'll see. If you get your calculator around, mess with it, and you'll find that out. If you can't, just drop me a message and a screenshot of your calculator, and I'll tell you exactly how to do that on your calculator. Okay? Right. Same again though. If I tell you x is 0.1, 1, 2, 3, 4. Okay? Doesn't have to have the same gap between them. The only reason we got 0.1 is because we can't have log of 0. If you put that in, you're going to get an error. Okay? Putting this in, then your calculator, log base 10 of this, give you -1, 0, 0.3, 0.5, 0.6, so on and so forth. Everybody here is capable of drawing that graph out. Yeah, matching those numbers up. And remember, it's meant to be curved. I don't see anything like this. It doesn't look like that. It's meant to be curved. Yeah, it's really meant to be curved. Now, the link between log and, so if I tell you y equals to 10x, this is where the book's awful, absolutely awful. Now, that's the same as f of x equals to 10x. Agreed? Okay, so I'm writing y equals to 10x. I'm doing ln y equals ln 10x. Agreed? Then x comes to the front, ln 10, that's ln y. Agreed? Hopefully. Now, what I should have actually done, sorry, I should have put not ln, I'm going to explain why. We do log base 10, log base 10, log base 10, log base 10. We put this number as the base. Okay, I'm going to do another one now in a second. So, log base 10, 10, that's one of the rules of logs. If I got log base 20, 20, that's 1. So x equals log base 10 y. Okay, so now that is our inverse equals to that. Yeah, so if I'm drawing that out here, this is our line y equals to x. This is the inverse. You're drawing it out like this. That's y equals to 10x. Now this is log 10y. And if you put that in, and we get rid of y, because that is now f inverse of x equals log 10x, like we did in the previous one. You could do up your tables, you could find out the points, and you could do that out there. The other example is y equals to ex. Yeah, that's f of x. So ln y, ln, because it's the base e, perfect, that's ln e, disappears, x equals ln y. If I'm drawing that out, again, one goes like this, and the other one goes like this. Everybody's capable of drawing it out. It's not rocket science. Now, where they ask you, there's two more things that we've got to get through here in the examples. In the book, okay, the last explanation in the book, I wouldn't be happy with. But example 3 says, if f of x equals to a bx, okay, as shown in the diagram, okay, and I'll draw out the diagram. This point here is 0, 3, and this point here is 1, 6. Obviously, we look at this and we don't know where we're going with it, but we apply enough intelligence that we've got 2 points. Yeah, our y point here is 3, our x point is 0. Anything to the power of 0 is 1, so a equals to 3. So therefore here, y equals to 3bx. Now we need to find out what x is. This y value is 1. The x value is 6. And, or sorry, the x value is 1, the y value is 6. We substitute 3b equals to 6, b equals 6 over 3. Therefore, our function is f of x equals to a, which is 3, so I'll do brackets next, b, which is 2 to the power of x. Now, if you go along and you say 3 by 2 is 6, so that's 6x, no, this is 2 to the power of x, and this is 3 to the power of 1. Different, you can't be doing that. Right, The last thing that you need to know is when they come along and they give you one of these functions in kind of wordy question. So everybody here can look at the example 4. I'm going to do another example myself. Let's say 18. And if you don't want to see how 18 is done, then look at this after. Okay, so the amount 80 micrograms of certain radioactive substances remaining after 2 years decreases according to a formula of AT equals to AO E 0.002T. Okay, how many micrograms were present initially? Right, so when we're looking at this question here, we're hearing micrograms, we're hearing all this stuff. We're not really trying to get our head around that. But all we know is that this is the start. Yeah. And this is time. And this is at any given point. Yeah. So, if I'm trying to work this out, AT is our Y value. And that's our X value. If we're looking at a graph. But they say 600 grams are left. So 600 is there. AO is E to the minus 0.002 by how many years? 1,000 years. Put that in. AO equals 600 over E to the minus 0.002 by 1,000. Put that into your calculator, you get an answer. Okay? Part 2. Now we've got an answer for this. Now I'm not going to give you the exact answer here because I don't have my calculator on me. A half-life of a substance is the time taken for the amount to decrease to half of its initial amount. Okay? Now, let's say AO, just for sake, is 5 or 10. So half of AO, the initial amount, will be 5. So it's decreasing. Yeah? What is the half-life for this? Now, when they say the half-life, they're looking for T, the time. What is the half-life? So if I'm putting this in half-life, let's say it was 5, and this is 10. Let's say, now this isn't 10, but I'm just making it easier. Now we've got E to the minus 0.02T. I'm left with this. The 10 divides, that's a half, equals to E, blah, 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 blah. I want to find out what this is. Now this is back to algebra. This is, well, it's the algebra part of logs. I want to get this down. That's ln E minus 0.02T is ln a half. I ln both sides. Great thing about ln E, it's just going to disappear. Okay? Then that's going to be that comes to the front of ln E. Ln E is 1. Ln a half is that. And then T is going to equal to ln a half divided by, and I'd leave this all to the end, 0.02. Now, ln a half is a minus number. Ln anything below 1 is a minus number off the top of my head. So this is going to come out positive. We cannot have a minus time because time is never minus. Time is always positive. Yeah? So what would time be? Time is or plus. Homework that I'm going to get you to do. Right. So Friday to Sunday, 2 days of work. I just want you on Friday 45 minutes and Sunday 45 minutes. So something along the lines of maybe 1 to 10 and then 11 to 20. Something in around that. You're completely responsible for your own learning here. I know that you think that the mocks are coming up. You'd be less likely. And yeah, I'd be okay if some people produce that on the Monday, because we're going to have this course done after the next topic. So it's up to you in this circumstance, because I know you are working, or most of you are working.